Okay, our last unit to review is Unit 3, Bonds. Make sure you, you read over the objectives and the topics. If we're going to go over the fill-in-the-blank review here. Valence electrons are responsible for the element's chemical properties. All right, so they're responsible for how the atom interacts chemically, why they bond with certain elements, why they don't bond with others. Why elements bond is to become stable, have a full outer shell, which for most of them means 8 valence electrons. Remember, hydrogen, though, only needs 2 valence electrons. Metallic bonds involve only metals. They're characterized by delocalized electrons, and we can also call that a sea of electrons. Ionic compounds involve metals or cations and nonmetals or anions. They're characterized by the transfer of electrons. Covalent molecules involve nonmetals, and they're characterized by the sharing of electrons. And remember, we can share 2 different ways, equally or unequally, and that's how we get nonpolar and polar. Cations are positive charged ions, and they're formed by losing electrons. And remember, metals always form cations. Anions are negative charged ions, and they're formed by gaining those negative electrons. Ions and atoms are stable if they have a full or half-filled orbital. Okay, you may need to make sure that you know your charges for your different groups. So group 1 is +1, group 2 is +2, group 3 through 12 varies, and we have to be told what that charge is, and we'll talk more about that in our next unit. However, zinc is always +2 and silver is always +1. Group 13 is +3. Group 14 we tend to skip over because there's lots of different things happening. Group 15, -3, 16, -2, 17, -1, and then group 18, our noble gases don't have a charge. Remember the diatomics. There's 7 of them. You can remember it by remembering the word Hofbrinkel, or if you look at the periodic table, start with number 1, go to number 7, and then draw a 7 with your finger. All diatomics have nonpolar bonding, and that's something where a lot of you were missing on your test. The Octet Rule states that all atoms must have 8 valence electrons, except hydrogen, who only needs 2. All right, I can't draw the Lewis structures here, but I can go over the steps to drawing them. So the first thing you want to do is add all valence electrons. Then you want to bond the outside atoms to the center atom. So bond all atoms to the center and subtract the electrons that you've used for that. Then you want to satisfy the outside atoms and subtract the electrons used. Okay, this is where it gets a little trickier. If there are still electrons left over, they would become the lone pair on the center. When you run out of electrons, That's when you need to check to make sure everybody is satisfied. And you can double bond if needed. So try these on your own, and I'll have them on the answer key. I just can't draw them on the computer. All right, looking at the chart below, we're filling in the type of atoms. So metallic bonds are made of metal atoms. Remember, that's to the left of the stairs. Ionic, metal and non-metal. So you have something on the right and something on the left. The electronegativity difference would be 1.7 to 4, 1.7 or higher. Polar covalent, you have two different nonmetals, and they have an electronegativity difference of 0.3 to 1.7. And then nonpolar covalent is typically the same nonmetal, like your diatomics, and they have a difference between 0 and 0.3. Number 14, again, I can't draw these Lewis structures, but I can tell you how to do them. So the first thing you want to do is recognize that it's an ionic compound this time. So we're going to use the dot diagrams. So you're going to draw the dot diagrams for the atoms. Remember, the dots are the valence electrons, and you can figure out the number of valence electrons from the last digit of the group number. Then you're going to draw an arrow moving the valence electrons, or the dots, from the metal to the nonmetal. The metal should end with no dots around it, and the nonmetal should end with 8 dots around it. Remember, you can add more metals or nonmetals as you go in order to get that to work. So again, you can go ahead and do A and B, and then you can check your answers, and I'll have it on the answer key. I just can't do it on the computer. Intermolecular forces, remember, these are forces of attraction. They're not an actual bond. Our London dispersion force is the weakest, and therefore it has the lowest boiling point. An example is any of the diatomics. Another example would be CO2, because that is a nonpolar molecule. Dipole-dipole, we're talking about polar molecules, so the strength is a little bit stronger, and they have a higher boiling point. And an example would be pH 3, where the center atom has a lone pair around it, or a lone pair making it polar. Remember, anything that's not symmetrical is polar. Hydrogen bonding, remember, is for any atom that has hydrogen bonded to F, N, or O, fluorine, nitrogen, or oxygen. It is extremely strong. And it has the highest boiling points, and it would be water, ammonia, and hydrofluoric acid. Properties of bonds, we made a whole foldable of these. Metallic bonds are malleable. I don't know why it's underlined. Let me fix that. They are also ductile. They have luster. They have high melting and boiling points. They conduct when a solid. They'll also conduct when they're liquids or gases. We just don't tend to see them in the liquid or gas phase. And then the last one is that they don't dissolve. They're not soluble in water. Ionic compounds are hard, rigid, brittle. They have high melting and boiling points, and they will conduct when molten or dissolved. Remember, molten just means that it's a liquid. And they do dissolve. They are soluble. Covalent molecules have low melting and boiling points. Remember, nonpolar has the lowest. They do not conduct ever. Therefore, they are insulators. Polar covalent will dissolve. Nonpolar does not dissolve. All right, molecular geometry. If we have a molecule that has one or two atoms attached with no lone pairs on the center, it would be linear. An example of that is CO2 or any of your diatomics. Bent, you have two things attached to the center with one or two lone pairs. An example would be water. Trigonal planar, you have three atoms attached, no lone pairs on the center. An example would be SO3. Trigonal pyramidal, you have three atoms attached and a lone pair on the center. An example would be NH3. Tetrahedral, remember tetra means four, so there's four atoms attached and no lone pairs on the center. An example would be CH4. All right, how do you know if a molecule is polar or nonpolar? Polar is asymmetrical or not symmetrical, and it has lone pairs around the center. Nonpolar is symmetrical, and it has no lone pairs around the center. All right, go ahead and try those problems, and then you can check your answers.